Okay, so let's get some quick context to start out with. So far in this course, what have we been talking about? We've been talking about developing propositional logic, so this is our propositions, our logical operators to connect propositions, and equivalences, and rules of inference arguments. So this is essentially the basis for rigorous arguments. Close this window. So today, we're going to change topics and start introducing sets and functions, which are the basic mathematical objects that we will be working with, or that all mathematics essentially is written in terms of. So introduce sets, steps, sets and functions. So just as a quick course structure comment, we spent yesterday essentially talking about proof strategy and inspiration for how to find proofs. And I want to spend more time talking about that. So that's part of the reason that I'm going ahead to the next section now, is so that we can build up some of this machinery. And then I have some nice examples of how to come up with proofs and how to think about proofs that I want to do next week in terms of some of the sets and function stuff that we'll be talking about. So look forward to more introduction to proofs next week. But for now, let's start with this. A set is an unordered collection of objects. If this definition sounds a little bit vague to you, it basically is. And the reason that we're doing that is that to define sets in a really, airtight, precise way is a huge pain in the butt and totally not worth it for the kind of things that we're going to be doing. So for our purposes, this definition is going to be perfectly fine. Set is essentially what you imagine it to be. It's just a collection of objects where we don't care about the order, we don't care about duplicates. So let's introduce some notation. The objects that are in a set are called its elements. And we write, let me do this nicely. So this symbol means that you are an element of a set. So little a is an element of the set big A. So this thing is a set, which is traditionally denoted by an uppercase letter. And this thing is an element of that set, which is traditionally denoted by a lowercase letter, and usually even the lowercase version. Usually the lowercase version of the same letter. So it's clear that it belongs to that set. So there's plenty of situations where you run out of letters and you can't do that. Perfectly fine. But when you have enough letters, it's very clear to write this way. And so this symbol these kinds of symbols you read as little a is contained in big A, or A is an element of big A, or even just little a is in big A. So well, one more quick thing. Also, if you put a strike through it, this means little a is not in big A. So it's not an element in this set. So let's have some examples. So we usually denote sets by braces, so curly brackets. So here is, all right, I'm going to get sloppier later, but let me try and write them a little bit nicely for now. So here is the set of positive integers less than 5. This is just some set. It has 4 elements. They are the numbers 1, 2, 3, and 4. We can have other things. We can have, for example, negative root 2 and positive root 2 is the set of solutions of the polynomial x squared minus 2. This is some set. It has 2 elements. They are negative root 2 and positive root 2. Okay, so, lots of examples, write down as many as you want. Here are some particularly important ones that you might see more than others. There is this guy, which is also denoted like that, which is called the empty set. It has no elements. And this is the kind of thing that, one of the, a little bit downsides, not the worst, but if you're being rigorous, you have to worry about edge cases. Things that happen on the, on the boundaries of things that you have to sort of deal with separately and are annoying, but usually not too difficult. So you'll often see the empty set popping up in cases like this, where, it's not super, I don't want to say it's not useful, but it's usually not the center of attention. It's usually just like an edge case. And here is some common notation for sets that you will see. Notation for some common sets. Sets of numbers are often written with these like double struck or blackboard bold letters, or just bold letters. If you look in the textbook, I think they use just regular bold. But if you're writing them down, it's nice to use this double struck because bold letters are hard to write. So N stands for the natural numbers, which are 0, 1, 2, etc. This double struck Z, which it's pretty good, is the integers. So positive and negative. And Z comes from the German word for number, which is Zahlen. What else do we have? We have Q, which is double struck like that, which is, well, rational numbers. I don't know if I have a great order to write them down, but -1, but it's also got like -1/2, -2/3 and stuff. Then positive rational numbers. Q stands for quotient, because they are quotients of integers. And then finally, R is the real numbers, called R for obvious reasons. And C is the complex numbers, also called C for obvious reasons. And if you're not familiar with the complex numbers, then don't worry about that. I don't think they're going to be used almost at all in this course, but they're a neat thing and quite useful if you ever run into them.